So starting the recording, and we are going to solve the
Sir,
homework.
before we begin, আমার স্যার আমার আম্মু বলেছিল আপনাকে ইয়ার ছবিটা ফরওয়ার্ড করে দিতে, পেমেন্টের ছবি। সো আমি করে দিয়েছি।
আচ্ছা ঠিক আছে বাবা, থ্যাংক ইউ ভেরি মাচ, থ্যাংক
আর
ইউ।
অলসো স্যার, অ্যাবাউট দ্য রোল নাম্বার, আমি এখনো রোল নাম্বার পাই নাই। আপনি যাকে মেসেজ করতে বলেছিলেন, আমি মামুনুর রশিদকে মেসেজ করেছিলাম, কিন্তু আমি রোল নাম্বার পাইনি।
আচ্ছা ঠিক আছে, নুরজান আবরার, আমি মামুনের কাছে রোল নাম্বার নিয়ে আমি তোমাকে রোল নাম্বার দিয়ে দিব, সমস্যা নাই।
ওকে স্যার।
I'll make it happen for you, no big deal. আচ্ছা, so let's have a look. The question says a train 100-meter long stops in a station with its front bumpers in line with the lamppost on the platform. Later it starts off with an average acceleration of 0.6 meter per second square. What will be the average what will be better. What will be the speed of the train when the tail bumpers passes the lamppost? So what is the part that what this question actually means? If this is our platform, and here is a certain lamppost, the train is currently, let's say train is this much long, which is currently at this position right over here, and the length of the train is exactly 100 meter. So it will start off and start going forward. From this point, it is gonna go forward at an uniform acceleration of 0.6 meter per second square. The question is, what will be the speed of the train when the tail bumpers pass the lamppost? Which means as the train moves forward, eventually when the train will reach to a point where the tail bumpers are aligned with the lamppost, what will be the instantaneous speed, final speed at this point? So initially the train is starting from rest. So it says that a train stops in the station, which means initially it was rest. So basically what it means that we have the acceleration available, we have the initial velocity available. We want to find out the final velocity, and the total length the train will cover in this process is 100 meter. So this distance would be equals to 100 meter. So we can go for the fourth equation, which is v square equals to u square plus twice s. So place it out directly as is. You're gonna get v square equals to 0 square plus 2 into 0.6 into 100. Therefore, your final speed is gonna be, find it out by the calculator. I'll do it for myself as well. 0.2, sorry, 2 into 0.6 into 100 root over gives us 10.95. So in case I can write this as 11.0 meter per second. That's pretty much it. The reason I gave you this question is to give you an idea that we are using the length of the train as the distance covered, and that's why the whole idea of the lamppost came in. That the train started where its front bumpers are aligned with the lamppost, and we are trying to calculate the final velocity when the when the train goes all the way down to the next point. That was for question number 1. Question number 2 says a projectile is fired vertically upwards, which reaches a height of 120 meter. Find the velocity of projectile u and the time it takes to reach back to earth. So this is a simple question. If I try and draw the image of this thing, it says we have a projectile which is shot vertically upwards against gravity with some initial speed, and it will eventually reach up to a maximum height of 120 meter. So this height, maximum height, is 120 meter, where momentarily the final speed at this position is gonna be 0, and beyond that point the projectile is definitely gonna start falling backwards. The first part of the question is asking us that how much was the initial throwing speed, and then it is asking us how much will be the total time it takes to travel the whole distance before coming back to earth. So how much time it takes to reach back to the earth. So finding out the initial velocity is actually pretty simple, because we know in this case the acceleration would be minus g, which is minus 9, not minus 9.81. For your level, we're going to use 10 meter per second squared. So for the first question, what we're trying to get, try to have a look at, I'm going to write all the variables over here. We know only for the upward motion, the final velocity of the upward motion, final velocity would be 0. Initial velocity we want to find out. Acceleration is minus 10 per meter per second squared, and the displacement, vertical upward displacement, is a positive 120 meter. So these are the four variables that we have available. So we're going to go for the fourth equation because t is the missing variable here. So we're just going to apply that. B square equals to u square plus twice as. So I'm going to place all the numbers. 0 square equals to u square plus 2 into minus 10 into 120. From here, you can easily find out the initial velocity. Take it out. It's 20 into 120 root over 48.99. So about, I'd say 49.0. I'm getting 48.99. I'm just writing this long number because I want to use it for the further calculation, or I could also in 3SF, I could write this answer in 49.0 meter per second. If you want, you can only write 49 meter per second. That will be 2SF answer, equally acceptable, no big deal. And then the question is asking us that how much time would it take before reach back to the earth. So we have to calculate the rising time, also the falling time. Obviously, it's much too easier if we go for directly calculating the rising time first, and then we can multiply it by 2 because that's what we're trying to get at. Or we can also go by the basic idea of this total displacement. When the stone will be back onto the surface of earth, it will have zero displacement. So I'm going to do this in two different versions as I've done earlier. You can choose any one you like. If I'm only going to find out the time to reach maximum height, this can be found very easily. You can use the formula v equals to u plus at because we just calculated u. So I'm just going to go for that. V equals to u plus at. Here the final velocity is 0. Therefore, initial velocity would be 49.0. I could write 48.99 as well. I don't think it's going to make much difference. So I'm going to go for 49.0, no big deal. Plus minus 10. 1 into t, which gives us about 4.9 seconds. This is the rising time. Therefore, total time to fall to earth is just double of that, which gives you 9.8 seconds. That's one way to go for it. It's pretty simple, but you just have to do, be careful to multiply it for the final multiplication by 2. Many students sometimes forget this. They get this value and forget that they are doing it for the whole time. So be careful not to miss out this part. Or you can really go by the second order equation, which is s equals to u plus, s equals to ut plus half at squared. So when the stone would eventually come back all the way down, its effective displacement would be 0. So you can place that 0 over here. 0 equals to 49.0 into t plus half into minus 10 t square. So ultimately you get 5t square minus 49 t equals to 0. So that gives you t equals to 0. That is one of your value. The other value will be 49 by 5. Gives you exactly 9.8 seconds. Both of these answers are acceptable for a 0 displacement value, but we are not going to pick up the 0 second because the question was asking us that how much time it takes to reach back to earth. So therefore, time to reach back to earth equals to 9.8 seconds. That's it for question number 2. Any questions so far? I'm sort of streamloading through the solution process because I have explained how these maths work earlier, but still, if you have any question in between or any of your working is not matching, or if you have any conceptual question, like for example, why this value is positive, why this value is negative, you can ask me. You should ask me. All right. Number 3. Acha, এক second, I just need to make. Sorry. Question number 3, the value of a cylinder containing 12 kg of compressed gas is opened and the cylinder empties in 2-minute time. The average velocity of exhaust gas is 25 meter per second. Find the force exerted on the cylinder. Acha, it's a very nice question. Let me draw this figure for you so that you can have a bit of understanding what we're trying to get at. Here, the question does not involve any mention of the earth or anything like that. So for the sake of simpler visualization, we're going to consider the cylinder and the gas to be in a zero gravitational field, or try to visualize entirely empty space with nothing in vision, not even stars, nothing, like totally empty space, in which we have a gas filled cylinder. This is a gas filled cylinder. And let's say right over here, we have a valve which is about to be opened, and we have some gas that is trapped within this cylinder. And whenever we'll open this valve, the gas is going to come out, and all the gas is going to come out. The average velocity of this gas, and we are using the term average velocity because you do understand that initially the cylinder would be at a much higher pressure. So whenever we'll open the cylinder, the gas would be coming at a really high speed because the rate of output would be very, very fast. As the cylinder slowly becomes more and more empty, then the rate of gas exhaust would become slowly lower. So you'll have a very high rate of exhaust gas, or you have a very high velocity of exhaust gas at the beginning. As time will go by, slowly that rate will decrease. Slowly that exhaust speed will decrease. Now, how much decrease are we going to experience? Is that can be linearly decreasing, that can be exponentially decreasing. Well, I'm not getting into that discussion because that requires a whole lot of discussion about gas behavior and whatnot, which you're going to learn in your A2 level. Hopefully you reach up to there. But what we need to understand that for the sake of simplicity, the question is telling us that total exist of the gas out of the cylinder is taking a total time of 120 seconds. It says 2 minutes. And the total average speed of the gas was 25 meters per second. And what you need to understand, when the gas was inside the cylinder, the initial velocity was essentially 0. Initial velocity of the gas inside the cylinder was essentially 0. So as the gas will come out of here, they're gonna come with some velocity. So we're gonna have some momentum produced of these gas molecules. So let's say the gas molecules are producing some momentum of delta P of gas in this direction. This essentially tells us by Newton's third law, or by the law of conservation of momentum, that the cylinder, partially filled cylinder, eventually which will become entirely empty, the partially filled cylinder will also experience an equal amount of momentum change in the opposite direction, which I'm writing as delta PC for the cylinder. But they should be equal and opposite to each other. এই আইডিয়াটা বুঝা যাচ্ছে কিনা? The momentum change of the exhaust gas would be exactly equal to the momentum change of the cylinder, which will happen over a duration of total 2 minutes. So what I'm going to write like this. I mean, mathটা করতেছি, তোমরা দেখো, further যদি না বুঝো আমি definitely question answer করব. So I'm going to write this, that change of momentum of cylinder equals to negative change of momentum of gas, which can be written as negative this is the actual equation. Actually, this is the actual equation for in terms of vector quantity. If I try to like কিছু পড়তেছে, never mind. So if you go for only the magnitude, so if I just try to write the magnitude, so I'm going to write modulus over here. If you wonder why am I giving modulus, because in this case for a linear scenario, the plus and minus sign actually handles with the direction. If you want to go on with the minus sign, perfectly all right, no big deal. I want to go with the modular sign because I want to show you that this is also a method applicable that you can apply whenever you actually understand the duration thing, which is not very difficult for a simple case like this. And you can go for just calculating the numbers, providing as long as you keep in your head that the duration of the momentum gain of the exhaust gas and the duration of the momentum gain of the partially filled cylinder or partially empty cylinder are going to be in exactly opposite direction. As long as you remember that, it's perfectly all right. So this is going to be a total of how much was the total gas compressed? It contained 12 kg of gas. So I'm going to write mass into delta V of the gas. So G, I should have written G. So this should be mass into final velocity minus initial velocity. We had a total mass of 12 kg over there. Final velocity was 1225, initial velocity 0. So how much do we get? We get 300 kg meter per second. This is the total momentum change of the gas. So cylinder should experience the same amount of momentum change. And then if you're trying to calculate the force is given by change of momentum over time. Force is defined by Newton's second law as rate of change of momentum. So I could write C over here because we're trying to calculate the force on the cylinder. So force is experienced by the cylinder would be delta PC by T, which would be equal to 300 divided by 120 2-minute Newton. So if you divide that thing, you get 2.5 Newton. See if it makes sense. Have a look at the question, have a look at the math, and see if this makes sense. If you have any question, please ask it. I'll give you some time. This is a new type of map. We haven't done any mathematical calculation of this sort earlier. I haven't showed you any example before, so I'm going to give you some time to appreciate what happened here. This equation that you see over here is pretty much the very basic preliminary mechanism by which any rocket propels forward. This is pretty much the first block of knowledge that goes into rocket propulsion. Change of momentum should be equal, so force would be gained by the cylinder.
Is the average velocity the final velocity? Question is, sir, the average velocity of the exhaust gas is 25 meter per second. Sir, এখানে তো স্যার আমরা এটাকে final velocity হিসাবে treat করলাম.
Yes. Your question is why?
Yes, sir.
Beautiful. The idea is that when the gas was trapped within the cylinder, for a stationary scenario, that cylinder can be considered to be stationary. So within the gas molecules are actually moving back and forth in random direction. That's what we call Brownian motion. But the resultant velocity of all the gas molecules combined together when they are trapped within the cylinder is essentially 0. They're not altogether going anywhere. The moment we let the nozzle open and let the gas exit out of the cylinder, at that point, all the gas should be moving in a specific direction. That basically gives you an idea of velocity because they're going to have actual displacement with respect to the original position. Try to get that idea first, that whenever you have actual displacement, that displacement over time gives you the idea of velocity. So initially the gas was at rest within the cylinder. That's why we place U equals to 0. And then as the gas comes out, and now you might wonder that this gas is coming out and eventually this gas should be doing what? This gas should be eventually become, I mean, this gas might actually become to rest. Should that happen or not? Here's the deal. Like I told you earlier, that try to assume a scenario where there is no gravitational field. This is just this whole thing. Consider this whole thing is an isolated system in space. There's no gravitational field, nothing. So if the gas particles actually exit out of some velocity over here, they are going to keep maintaining their journey to the right for infinite distance. So basically what I'm trying to mean is that whenever the gas were exiting out, the inside gas, the remaining gas which was inside, that was pushing the leaving gas out. That's what produced their velocity of the leaving gas. And the average of those velocities, which is not going to be exactly same throughout the whole exit process, average of that velocity is mentioned as to be 25 meters per second. So for the scenario when the gas is coming out of the cylinder and as it is leaving from the cylinder, not considering what happens really further down the line. I mean, what's going to happen at the very end of the scenario for the gas particles? Well, if you consider an isolated system, they should keep on moving at that velocity, because you have to understand Newton's first law. It says what? As long as nothing interferes with the state of motion, objects will maintain their motion. So if you don't apply any resonant force on an object should be maintaining that velocity. So if you consider an isolated system, those gas molecules which are coming out of the cylinder, they should be able to keep maintaining their velocity. So if you try to visualize the final velocity in a much bigger aspect, it still would be that 25 meters per second, which is the average velocity of all the gas molecules as they are coming out. Does that answer your question? বুঝা গেছে কিনা? All right. So let's go for the next problem, which is number 4. Okay, I'm gonna bring up the next image because we have a part of question number 4 over here. Don't move. রাফিদের ফ্লাইট কবে?
Sir, first next month এর first তারিখ।
আচ্ছা, ও এই সেশন থেকে জয়েন করতেছে তাই না?
জি স্যার।
Beautiful. Okay, let's have a look at question number 4. We have 2 parts of the question right over here. A breakdown truck or a tow truck. You kids do understand what a tow truck is, right? So for those of you who do not understand what that is, let me just show you. Tow truck is basically the record that we have, which city corporations used to these are what we call the tow trucks, which are basically vehicles which will lift up a car and take from one place to another place with no person inside. More commonly used if a car is totaled, or if it has gone into some destruction that it cannot be run by other cars or anything like that, if it cannot drive itself, or in other cases if some car is kept somewhere illegally, where the police department, law enforcement departments can actually tow vehicles and put them in a certain place where the people have to pay some fine and eventually get back their vehicle up. Tow truck is basically the car which pulls other car like that. So let's have a look. The question says, a breakdown truck or tow truck tows a car of mass 1000 kg along a level road and accelerates at 0.5 meter per second squared. Try to understand. Let me just try and draw this scenario for you. So let's say this is the ground. Here is the tow truck, sort of like a pickup, coming up the towing mechanism, and this is the hook. Okay, this is the hook where we have the towed car right over here. A very beautiful drawing of multiple cars, obviously figure not drawn to scale. Okay, let's say this is the scenario. The question says that it is going along a level road. Having a level road means that we don't have to bother about the component of the weight, which is very nice. And the mass of the car, this car has a mass of 1000 kg. And mass of 1000 kg along a level road and mass 1000 kg along a level road and accelerates at 0. Did I give 0.5 or 0.6? 0.5, right?
Yes, sir, 0.5.
0.5 meter per second squared. In this case, I'm showing to the left. I drew the figure like that. Actually, we could have considered the other way around. I could have drawn it the other way around. We could consider negative sign, but I'm not going to do that for the scenario because it's just a single linear motion. And accelerates at 0.5 meter per second squared. What is the tension in the tow line if road friction is 500 Newton? So try to understand. The question is telling us that the road friction on this car is a total of 500 Newton. To be able to create this much acceleration, this tow truck has to overcome this 500 Newton of friction force, then create a total of 0.5 meter per second square acceleration. Let me show you it in a much easier format. Let's say the pull of the tow line, let's say this is tension T, which is basically the question that what is the tension in the tow line. Tension in the tow line basically means that how much pulling force is the tow line applying on the car. Let's say the tension is over here in this direction, and frictional force is working against the motion, that is 500 Newton. And the resultant force would be responsible to produce this much acceleration on the car. So if I go for the equation of Newton's second law, it should give us that resultant force in this case is coming from T minus 500. So tension force is bigger because the car is actually accelerating forward at a value of 0.5 meter per second squared. এই ইকুয়েশনের ডেভেলপমেন্টটা বোঝা গেছে কিনা? বাকি পার্টটা সিম্পল. And then if we're going to apply some values over here, resultant force should be given by mass into acceleration. Tension minus 500. According to the question, mass is 1000. The effective acceleration of the car was 0.5 meter per second square. So T minus 500. So ultimately you're going to get T equals to 500 plus 500. Wow, that is 1000 Newton. That's for the first part. In the second part, it says the tow line breaks when the truck and car both reach 36 kilometers per hour. So they are both speeding up, and whenever their speed reached 36 kilometers per hour, this tow line got broken. So it got disconnected. How far will the car travel before coming to rest if a braking force of 5,000 Newton is applied? Now, this is a new information. Try to understand. How far will the car travel if a braking force of 5,000 Newton is applied? Now, this essentially means when the tow line got broken, the instant the tow line got broken, there must have been a certain person over here, or there should be some autonomous system within the car which would apply brakes onto these wheels, which is going to apply a braking force of 5,000 Newton. Now, the question is how far this car will move before coming to rest. This is actually a pretty simple problem, but because of the ambiguity within the question, this question can be approached in two different ways. Just a second. তোমার তোমরা একটু এই প্রবলেমটা ট্রাই করো, আমি আসতেছি। ব্রেক 5 minutes. Okay, so there are two different ways we can go. The first thing is that there's a little bit of ambiguity in the question. The question says that when the brakes are applied for the car, it applies a braking force of 5,000 Newton. Now, is this 5,000 Newton additional to the original 500 Newton, or is the total braking force, which basically comes from the friction of the tire with the road, level road, that is altogether 5,000 Newton? We're not clear about that. So for this math, we could use either of this value. Either we could use 5,000 Newton itself, considering that is the total braking force within which 500 Newton is included. We could go for that method, or we could add up these two forces and use that number for our calculation as well. The reason I gave you a misleading question, sort of misleading question like this, is to give you an idea that sometimes question paper can have this kind of questions, and if it so happens that the question itself on its by its own virtue is somewhat ununderstandable, or the question data is a bit ambiguous, in those cases you're gonna apply your best choice. Don't do both the options, don't do both of them. You're gonna apply your best choice, and both of the answers would be logically acceptable. So I'm going to do the math for both of them, braking forces over here. So let's say if we take the total braking force to be only 5,000 Newton, in that case the acceleration, or to be honest in this case deceleration of the car, should be 5,000 divided by 1,000, gives you 5 meters per second square. This is going to be our deceleration, and the initial velocity was 36 kilometers per hour, so we might as well convert that into meter per second. So I'm going to show that initial velocity is 36 kilometers per hour, which is 36 into 1,000 divided by 3,600 meter per second. 0, 0, 0, 0, 36, 36 bad. We have 10 meter per second speed. So in that case, and obviously the final velocity before it comes to rest, which means that should be 0. And we are asked to calculate the how far travel should it travel before coming to rest. So we are asked to calculate the displacement. So if you have a good look in the equation, we have acceleration A, we have initial velocity U, we have final velocity V, and we are trying to find out S. These four variables are found within the equation number 4. So V square equals to U square plus twice AS. If we replace all the numbers, 0 square equals to 10 square plus 2 into minus 5 into S, which gives us 10 meter. That's one way to go for it. Or vice versa, you could do the same variables over here. This same equations number should be here, but we can consider, let's say the total braking force is gonna be 5,500 Newton. If that's the case scenario, in that case, our deceleration value is gonna be 5,500 divided by 1,000, which is gonna be 5.5 meter per second squared. In that case, if we apply the same formula, V square equals to U square plus twice AS, we're gonna get 0 square equals to 10 square plus 2 into minus 5.5 into S. So you just need to do a bit of a calculation for this one. S would be equals to 10 square divided by 11, 100 divided by 11. 9.09 meter. For this question, both of these answers will be equally acceptable because the question is not very specific whether this 5,000 Newton is additional to the original 500 Newton or inclusive. But basic procedure হচ্ছে আমাদেরকে ফোর্স থেকে আমাদের অ্যাক্সেলারেশন বাই করতে হবে, কোশ্চেন পরে বুঝতে হবে যে আমাদের কি কি ইনফরমেশন अवेलेबल আছে. We have the initial velocity available, final velocity is supposed to be 0 because the car should come to rest, and then we are trying to find out the displacement and choose the appropriate formula for that scenario and eventually go for the calculation as is. বুঝা গেছে কি?
Sir, in the exam, কিছু যে কোনো একটা করলেই হবে? Or
well, যদি এটা actually একটা MCQ question যদি এই পরীক্ষা এটা আসে, if this question shows up in an MCQ paper, then you are definitely not going to have both of these answers. You're going to have only one of this. And then if you apply for, let's say, for 5,000 and you get this number, but the question actually gives you 9.09, then you need to retry it for 5,500. And if you get 9.09, then you should choose that. In an MCQ question, you would definitely not have these two answers. You'll not. But for paper 2, if this exact question shows up, then any of this operation is gonna score you full marks. You just have to specify clearly that here braking force equals to 5,000 Newton, or you have to write over here braking force equals to 5,000 plus 500 equals to 5,500 Newton. Either way, you're gonna get full marks. It sometimes happen. Questions can be a bit ambiguous at certain points. That was the whole point of this question, to introduce you to this kind of alternative working, provided the question's wording is not exclusive, to understand what should we take for our mathematical number value. MCQ answer হলে একটা আনসারই থাকবে, দুইটা থাকবে না। বুঝা গেছে?
Yes, sir.
Okay. Let's try question number 5. It says a bullet of mass 6 gram traveling at 120 meters per second hits a target and penetrates into the target while coming to rest within 0.05 seconds. Calculate the distance of penetration into the target, average retarding force working on the bullet. So let's try to visualize the scenario. Let's say this is the target. The target can be drawn to be pretty long. Let's say I'm giving a break sign. Break sign actually means the object can be further long, but we're only showing this much part because we're interested for this much part. The bullet was before when it hit the target. So at the point of hitting the target, or initial velocity right over here is equals to 120 meters per second. It enters into the bullet and eventually it goes further somewhat inside. And after going through a certain distance, it will eventually come to stop. So here, the final velocity inside the target can be a piece of wood, can be some other object. The final velocity is 0. As per the question, this whole process of deceleration takes an amount of time, which is 0.05 seconds. The question is asking us that how far should it penetrate? So how, if this is the distance of the penetration, I should have actually labeled from tip to tip. So a little bit of error there. So because I started it from the tip right over here, so the final line should go all the way up over here. That's much distance. How much is S displacement? And also, what is the retarding force or decelerating force that is working on the bullet? The question has also given us the mass of the bullet, so I'm going to write it up over here. The mass of the bullet happens to be 6 gram, or I can write 6 into 10 to the power minus 3 kg. So it's actually pretty simple. You can see that we have judge the values. We have the U available, we have the V available, we have the T available. We're trying to calculate S. So what is missing over here? If we just consider S, so have a look. We have S, we have U, we have V, and we have T. So এই চারটাকে ইনভলভ করে আমাদের যে ইকুয়েশনটা বিল্ড আপ হয় সেটা হচ্ছে আমাদের সেকেন্ড ইকুয়েশন, where acceleration is completely আমাদের অ্যাক্সিলারেশন বাই করতে হবে, যেটা আমাদের নেক্সট পার্টে আছে। বাট সিন্স ফার্স্টে আমাদেরকে বলছে ডিসটেন্স বাই করতে, সো we're going to try to find out the distance first. So this is our unknown, and these are the 3 variables which are provided to us. So if we're going to go for the second equation, which is S equals to U plus V divided by 2 multiplied by T. So place all the numbers and see how much you get. Initial velocity 120, final velocity is 0, divided by 2 multiplied by 0.05. দেখো এটা কত আসে। This is for our option choice A, and for option choice B, we are trying to calculate what would be the force. এখন ফোর্সের ফর্মুলা হচ্ছে F equals to ma. So আমরা যেহেতু m অলরেডি জানি, so টোটাল ফোর্সটা ক্যালকুলেট করার জন্য আমাদের অ্যাক্সেলারেশন বের করা লাগবে। So অ্যাভেলেবল যে নাম্বারসগুলো আছে সেগুলোতে খুব ইজিলি আমরা অ্যাক্সেলারেশন বাই করতে পারবো। Acceleration equals to V minus U divided by T, which is gonna be 0 minus 120 divided by 0.05. minus 2400 meter per second squared. And if we are trying to calculate the force, I have a minus over here because this is supposed to be deceleration. But and then to calculate the force, you can also keep applying the minus sign involved within the calculation, or you can choose to avoid it, because the question have already asked us what would be the average retarding force, which by virtue means this is going to be a force working in the opposite direction of the initial velocity, which is going to cause deceleration to the incoming object. So F equals to ma, which goes on to give us 6 into 10 to the power minus 3 multiplied by 2400. এটা কত আসে দেখো, I'm getting 14.4 Newton. দেখো বুঝা গেছে কিনা? I'm gonna put the whole thing in view. Any question? বলবান ওয়ার্কিং বুঝা গেছে?
Yes, sir. But what is the significance of seeing average retarding force?
Oh, average retarding force actually means what you need to understand, that as the object will actually penetrate through the object, it is going to experience some physical deceleration from this thing, and that is going to work sort of like it can be a bit of a elastic force, because let's say if this is an wooden object, when the object would have a higher speed, it is gonna come across bigger number of fiber, pretty much like air resistance. When an object goes to air at a high speed, it collides with bigger number of particles at a higher speed. So every individual collision leads to a bigger amount of force. But when the object moves slowly through air, it encounters smaller number of particles at a smaller speed. So each individual collision becomes less force, affects less force. And also the amount of force, because there are fewer number of collisions involved, also becomes lower. The reason we're using the term average deceleration or average retarding force, because initially the moment the bullet would hit the object, is going to experience the highest amount of force, because initially it would be incoming at a very high speed. As the bullet slowly slows down, the opposing force will also become weakened, and eventually, I mean, the way the force is going to work, I mean, right over here, if I try to draw a graph of, let's say, retarding force only by magnitude, so because there should be a negative sign involved, so I'm giving magnitude, retarding force over displacement, you're going to have a very high value at the beginning, right at the point when the object becomes stopped, you're going to have a pretty low value. So this is going to have a decreasing pattern. Now, I'm not saying this is going to be a linear decreasing pattern. It might be decreasing gradient, it might be increasing gradient, depending upon the object's property. But typically it is a decreasing gradient line. Now, we don't want you to bother about what are the intermittent values or in between values of the force individually. That's why we use the term average retarding force. So if we consider the total thing happening over an average deceleration, which is usually not the case, object always decelerates at a very high rate at the beginning, and the deceleration slowly becomes less as the object slows down further. But to avoid that complicacy within the physical problem, we are using the term average retarding force. It's something similar to the question that we handled for the gas cylinder scenario, that we use the term that the average velocity of the exhaust gas, because the total exhaust gas velocity wouldn't be the same over the same 2-minute duration. Similar thing. বুঝা গেছে? আচ্ছা, তোমাদেরকে আমি একটা সার্টেন কোশ্চেন সলভ করতে দিব। আমি একটা সার্টেন কোশ্চেন দেখে রাখছিলাম, দাঁড়াও বাই করতেছি। I'm sharing a PDF to you. This is October number 18, paper 22. It's question number 9 একটু তোমরা অ্যাটেম্প করবা। You don't have to print this out, just have the question out in your device and solve the question in your paper. You don't have to draw anything on the question paper. There is no such thing as to draw on the question. I want you to try this question. There is a certain significant idea about the whole stuff that we have learned over the last couple of weeks. So this is a good question to check all of your understanding in terms of word equation and also in terms of your capabilities. I highly recommend that you do not see the mark scheme. So I'd really appreciate if you don't go behind me and see the mark scheme. I'm gonna give this to you. Try out question number 9. Will this be going to you? দেখো তো এটা আসছে কিনা?
Yes, sir.
আসছে? হ্যাঁ, এটার কোশ্চেন নাম্বার 9, সরি কোশ্চেন নাম্বার 9 না, কোশ্চেন নাম্বার 8, সেকশন বি এর ফার্স্ট কোশ্চেন, যেটা যে ক্রিকেট ব্যাটের কোশ্চেন আছে এখানে একটা। এই কোশ্চেনটা পার্ট বাই পার্ট একটু ট্রাই করো। দিস ইজ a 15 mark question, so I'm gonna give you a bit more than 15 minutes. So let's say I'm gonna give you up to 9:15 to solve the whole thing, and do write all the descriptive answers as well to your best capability. And have a look at the space that you have. State what is meant by mass. You have 2 lines, so in your copy you should not write more than 2 lines. A sentence can be 2 lines long. If you can write in less words, perfectly okay, but don't prefer to write more than 2 lines, not two lines, 1 word, not even that. So try to make logical decision with the how long your answer should be. Although if it's a 1 number question, it might be actually very small. State what is meant by mass. If I was writing the answer, I'm going to write the property of an object that opposes its change of velocity is mass. That's the inertial definition of a mass. So any object which has mass will always oppose its change of velocity by Newton's first law. So it's the one way of defining this, but there can be other definitions as well. For example, the amount of mass within an object is actually the amount of material within that object. So that's also another way to say that. But anyway, you can write your own definition, and we can eventually look on the mark scheme and the examiner's report to see how far close could you get to the idea that the examiners are trying to get at. And then you have some mathematical question over here from the graph. You have to calculate some numerical values, and you don't have to draw anything. Nothing was asked to draw within this figure. So you just have to find out some numbers, and then you have some descriptive questions over here as well. I chose this number for a question for a specific reason, that there are quite a good number of descriptive answers over here. So if you have understood the concepts properly, then you should have all the mark scoring points within your answer. But there is no big deal if you don't have 1 or 2 of these points. Perfectly all right. This is what we call a class. This is not an exam. So you are perfectly allowed to do all sorts of mistakes over here, as long as you understand what mistakes you are doing. That's the whole point. So a question to try koro. We'll resume class at 9:15. Question number 8. I'm going to keep this in screen. Is there any question that within this question number 8 that you couldn't attempt at all, or the question altogether seemed untouchable? Any such thing? Anyone?
Sir, C. 8C.
8C. Let's have a look. Go there. Okay. Let's have a look. Question number 8C says, for the ball moving in the way shown, the effect of air resistance is negligible. When a ball with a much smaller mass is hit vertically upwards at the same speed, air resistance produces a noticeable effect on its motion. So there's 2 ways in which the velocity time graph for the ball with a smaller mass differs from figure 8.2. Beautiful question. So basically what they're asking us is that if air resistance was affecting this graph, then how would this graph actually change? What would have happened? I'll show you. Where is the print screen?
The graph had been more steep.
Sorry?
Sir, would the graph have the extra graph take care of steep হবে?
গ্রাফের ডিফারেন্ট জায়গাতে ডিফারেন্ট চেঞ্জেস আসবে, আমি সেটা পার্ট বাই পার্ট বলতেছি। First of all, here's the deal. Try to understand this part. Let's say when the ball is thrown without air resistance, let's say this is the green ball, which is the actual cricket ball. It was going upwards at initial 8.4 meters per second. Let's say it reaches up to this side and eventually it falls down. And then it almost immediately comes to stop, shown by this upward line. So this is the last deceleration reaching to the ground. So let's say this is the case for the without air resistance. Let's say with air resistance, when the ball is going to start to rise, initially at the point of hit, the speed is going to be this much, which is 8.4 meters per second. As the ball will rise upwards, try to think normally. In this case, we have air resistance working downwards. So because the velocity is upwards, the air resistance is going to work downwards. So for the upward motion, the air resistance is working vertically downwards. And the weight of the object is also working downwards, which means, and air resistance is a force which is dependent on the object's speed. If the object is moving fast, the air resistance will be more. If the object is moving slowly, the air resistance will be less, which means as the object will rise up, it's going to slowly have less and less velocity, obviously, which means the magnitude of this air resistance, downward air resistance, will also become lower. The point that I'm trying to get in your head is that initially at the point of throwing upwards, you're going to have a high value of air resistance opposing the motion. And as the object slowly slows down, the air resistance will slowly become less. And eventually when the object would actually become to rest, then the air resistance would become zero. So at the point of final velocity, let's say if equals to zero, air resistance would be momentarily zero, but the weight would still work vertically downwards anyway. The weight would be constant. You might see one thing, that I have intentionally drawn this point over here lower than the original height. There's a reason for this. The idea is that when for the green line, the downward acceleration was a constant minus 10 meters per second squared. There was no variation for this. But for the red line, which is with air resistance, the downward acceleration would be 10 meters per second squared downwards plus the acceleration due to air resistance. So both of these things would definitely cause us even a slightly bigger deceleration on the upward going object, which means it is going to slow down faster. That's why it's not going to be able to cover more distance. If you remember this thing, that how can I put this? Let's say v square equals to u square plus twice as. If you consider this equation, in this scenario, v is 0 and u is same for both of them. So I can write 0 square equals to u square plus twice as, where u is a constant. So twice as should be equals to minus u square, which is also a constant. So this product twice as should be constant. So this actually means that acceleration and displacement, these two variables should be inversely proportional, because the product of these two things multiplied by 2 should be a constant. Or if I try to show it in a different way, let's say if I take it out from here, as equals to minus u square by 2, which happens to be a constant. So a into s equals to a constant. So I can actually take this thing as a equals to k into 1 by s. If I take out the proportionality constant, I can write a proportional to 1 by s. Vice versa, I could have also written s is proportional to 1 upon a. So the displacement would be inversely proportional to the acceleration, because in this case we are considering two different scenarios where the acceleration is not constant, but they have the same initial velocity. You might wonder that if the acceleration is not constant, then why can we apply this equation? Well, we are applying this scenario for two different cases where the initial velocity and the final velocities are same, but the accelerations and the displacement are considered to be different, which is possible. Now, because the acceleration would be higher, or to be more precise, I should say the deceleration of the object would be higher, the object wouldn't be reach as much height as earlier, which essentially means, have a look over at this graph. This graph shows you what? This is the area that essentially shows you what? The total amount of vertical height above the ground. Is that correct? This is the initial upward velocity. As the object is slowly going upwards, its upward velocity is slowly becoming less, and eventually at this point, the upward velocity is momentarily 0. So this basically represents the maximum point above the ground. So this total area is the height of the object when the air resistance was not part of our deal. So if you consider air resistance, then essentially the object would not be able to reach that much height, which means the new area that we're going to try to draw is going to be somewhat smaller. And that obviously makes sense. So I can draw it up in this manner. Bigger deceleration at the beginning, decreasing deceleration at the end. So somewhat like that. Within the same amount of time, it works out for just fine. The time amount shouldn't be much too different. Actually, the time should also be less because v equals to u plus at, a is less. So time would be also less. So actually, I think this graph should be a decreasing gradient negative curve, which should cross the axis a bit earlier, because it shouldn't be traveling for as long when the air resistance is working. And then it should drop down like that with a much less speed than initial. And then this part should be exactly same as this. So these two lines should be exactly parallel, because this is this is a reaction force from the ground. But this is pretty much how, in my opinion, the speed is going to work out. I'll explain why I'm drawing it like this. What I'm trying to show that initially there will be a large deceleration when the speed of the object is high. As the object slowly comes to momentarily at rest, then the acceleration would be exactly equal to the gravitational acceleration. So at that point, you'll have the same acceleration as gravitational acceleration. And then as the object starts to fall down once again, so you have a bigger value of speed, your opposing deceleration would also once again start to work higher, which means the object is going to lose speed much faster. So that would actually give us a graph. So it shouldn't speed as much, which means it's gonna increase in a much decent pattern. So actually, this should be looking like that. I'm a bit confused. Acha, I'm marking like this. Just a second. One thing I'm sure that that this part should be steeper, and the total amount of time requirement should be smaller. These are two variables that I'm definitely sure about. But what should happen at the intersection point, I'm a bit confused about that. So I'm going to look about it, and I'm going to get to the answer and explain it to you. 22. Question number 8. 8C, have a look. Any two from smaller time to drop to zero velocity or hit ground. Okay. Line is not straight, or velocity does not change uniformly, or gradient is not constant. Smaller area under the first part of the graph and less distance traveled. Slower final velocity. Initial downward gradient steeper. I think we covered all of these parts. What I was confused about was this is not covered in the mark scheme. But see if you can make sense with all this information over here. Do you understand why there should be a smaller time to drop to zero velocity? Because of the increased deceleration.
Yes, sir.
And if it takes less time to rise up, obviously it's going to take less time to fall down as well, because it is not rising as much. Then this is one point. I mean, you can actually write any two from all of these points. So the further points say that line is not straight. So if you just write that line is not going to be straight, not mentioning how the line is going to be, you're still going to score 1 mark. Or you can say velocity does not change uniformly. Makes sense. Gradient is not going to be constant because you have a variable deceleration causing from air resistance. Any three of these exclusively is going to score you 1 mark. Try to understand. All of the horizontal lines that you see, each of those score you 1 mark. Not these 2 points. So if you write these 2 points, let's say line is not going to be straight because velocity does not change uniformly. If you write only these 2 points, you're not going to score 2 marks. You're only going to score 1 because both of these things pretty much mean the same physical property. So this information can be either expressed as saying line is not straight, or velocity does not change uniformly, or gradient is not constant. These 3 phrases mean the same thing. So any one of these 3 expressions will score you 1 mark. two of these three expressions will still score you 1 mark because it's the same thing said in different set of words. Do you understand? Each of these horizontal lines you see, they score 1 mark each. Each of these horizontal lines represent individually different information. This one was about the time requirement. This one is about the shape of the graph. So earlier it was straight. Now the new graph should be curved. The third point that we have over here, smaller area under the first part of the graph or less distance travel, which I just told you a bit earlier, that the object is not going to rise up as much. So there should be a smaller area under the first part of the graph. Then it says slower final velocity. That is obviously true because earlier the object would rise up under the effect of gravity and then eventually fall down under the effect of gravity only. But in this case, the object is primarily not rising up to the same height as earlier. That is one point of not getting the same velocity, it is losing some energy. And as the object will once again start to fall downwards, try to understand, as the object will start to fall downwards, air resistance will also start to work in the opposite direction of the velocity. So for both the rising up part and both the falling down part, we are actually losing a significant portion of our energy of the ball, which without the presence of air resistance would be completely conserved in the form of Gp to K and then K to Gp. Sorry, I said wrong. K to Gp and then Gp to K. If we consider for the motion of the green line where there is no air resistance, all of your initial kinetic energy will be converted to Gp as the object goes up, and as the object falls down from the highest point, all of that stored Gp will be converted back to K. There'd be no loss. But if you consider air resistance, as the object goes up, it loses some energy because it has to work against the air resistance. As the object falls down, it's once again have to do some work against the air resistance, so it has to lose some more energy as well. So both the motions is going to be responsible. Both the motions are going to be responsible for some amount of energy loss. So the object will not hit the ground with the same final velocity, which actually showed up over here, right up over here, with lower value of the final velocity. So it's more closer to the x-axis. And it says slower final velocity and the initial downward gradient steeper. Initial downward gradient steeper basically means this part that I just labeled over here, that you're going to have a much steeper initial gradient because of the higher air resistance added to the gravitational acceleration over here. So pretty much all the points that I've covered. What I was confused that how this graph should actually look like in terms of actual shape, but these points actually make sense. I'm going to look at the examiner's report for a while to make sense to see what the examiners have to say about this problem. Sometimes they actually provide some really good insight. This is paper number 22. So we're going to jump into that. 505422, question number 8. Let's have a look. Question number C. They didn't say anything very specific. They just said this. Only the strongest candidates answered this question correctly. Bam. So the examiners didn't feel like discussing all the weird or wrong or creative and wrong answers that the students came up with. So they just said one single thing and was done with their purpose. It makes sense somewhat. But বুঝে গেছে কিনা? তোমার কোশ্চেন আনসার পাইছো? আচ্ছা। Did any of the other parts did not match with you? You can look at the mark scheme. You can download it directly from the web, or I could actually deliver it to you because I have it in my hand. But you should definitely learn how to download your question papers. Many of you might know this already. If you don't, you should learn. It's pretty simple. As long as you can browse Facebook or other browsers, I think it's pretty simple to download papers from Cambridge and other places as well. Papa Cambridge or other websites. So I'm not going for the answer of the other questions. I hope you could solve them, but if you couldn't, I will help you in the next class. তোমাদের দুটো হোমওয়ার্ক দিয়ে দিয়েছি। তোমাদের একটা হোমওয়ার্ক ছিল হচ্ছে আমার ওই এক্সামিনার কি বলে লার্নার্স গাইড থেকে লাস্টের যে নেম হিয়ারিং গুলা, যে কোন কোশ্চেনে কোন ওয়ার্ডের জন্য কি রেসপন্স দিতে, সেটা আমি আজকে আলাপ করব চিন্তা করছিলাম। But then I started the class a bit late, then I had a bit of a disruption in between. I had a phone call that I had to pick up. So আমি এই জিনিসটা নেক্সট ক্লাসে অবশ্যই আলাপ করব। I'll not forget this ইনশাআল্লাহ। বেঁচে থাকলে অবশ্যই আমি আলাপ করব। আর হচ্ছে তোমাদের হোমওয়ার্ক থাকবে হচ্ছে এই চ্যাপ্টারের এমসিকিউ পেপার গুলা শেষ করবো সবগুলো ডেফিনেটলি। মানে হচ্ছে টাইম গ্রাফের একটা ওয়ার্কশিট আছে আপ টু টাইম গ্রাফ। টিকার টিপটা তোমাদেরকে আমি আলাদা করে পড়াইনি, টিকার টিপটা আমি নেক্সট ক্লাসে পড়াবো। টিকার টিপটা কেমনে হ্যান্ডেল করতে, ইজ ভেরি স্মল বেসিক ফর দ্যাট, নেক্সট ক্লাসে দেখাবো। তোমার টাইম গ্রাফ এমসিকিউ পুরোটা শেষ করবো। আর ফোর্সেস এর মোশনের যে পেপার 2টা আছে, এটা এক পাশ থেকে করা শুরু করো। সবগুলাই যে করতে হবে এমন কথা নেই, you can skip one and you can do every even problem, you can do every odd problem, you can do the large problems from the back and go forward, go backwards, so you can start at the end and then slowly go backwards, or you can start from the beginning, however you feel comfortable. So just try some problems from there, and if you come across some problem, I'll definitely help you to solve them. And if everything works out right, we are gonna start the next chapter, which is elasticity. It's a small chapter, but it's a different chapter, hopefully in the next class. Thank you very much. আর হচ্ছে আমি ইয়াকে নূর আবরার জাহিন, রাইট? তুমি রোল নাম্বার পাওয়া বলছিলা? নূর জাহিন আবরার,
স্যার
তুমি রোল নাম্বার পাও না, তাই না?
ইয়েস স্যার
ঠিক আছে, তোমাকে রোল নাম্বার আমি ম্যানেজ করে পাঠাচ্ছি আমি একটু পরে। থ্যাংক ইউ ভেরি মাচ। আসসালামু আলাইকুম।
Allah Hafiz, sir.